guess further, I'll welcome you to tonight's lecture. I'm Chris Gobler, tonight's speaker. I'm also the Director of Academic Programs here in the Stony Brook Southampton campus for SoMAS. And we have this seminar series on a regular basis. It's the first Friday of every month in the spring and in the fall. So we have two more lectures. After tonight's, we'll have Judy Weiss from Rutgers University speaking about salt marshes on the first Friday of May. And then the first Friday in June, we'll have Bruce Bronowell and Ann McElroy from Stony Brook talking about the Deepwater Horizon oil spill in the Gulf of Mexico. But again, I'm tonight's speaker, and I thank you all for coming. How's my mic working? Everybody can hear on the remote? Great. So you can see the title of my presentation tonight. This is part of something that we've been doing here in this campus for more than a decade called the Stony Brook Southampton Coastal and Estuarine Research Program. It's a collaborative research program with multiple faculty, many students. Hopefully you all got to see the student posters, which will be up afterwards. And the research is sponsored by the New Tamarin Foundation. And we have two major objectives of the research that we're doing. Firstly, we're looking to reduce the impacts of anthropogenic stressors on coastal ecosystems, and specifically we're thinking about things like nutrient loading, climate change, harmful algal blooms, and various pathogens. And secondarily, our objective is to maximize the distribution of fisheries and foundational species in our estuaries, bivalves, eelgrass, fish, and salt marshes. So, as the name indicates, we do this by conducting research, and our research is looking to identify environmental threats, but also to identify potential solutions of those threats. And another part of what we do is the reason I'm here tonight is that we're hoping to do research that we can then communicate with people so that the research can go somewhere and do something. So we're seeking to communicate with the public, with non-government organizations, and also with government officials. So for tonight's presentation, I'm going to give some background research. I see some familiar faces, but also some new faces. So I want to make sure we're all on the same page when I start talking about things like nutrient loading and harmful algal blooms. So I'll give a little bit of background. I'm going to try to talk a lot about research that's been done in the last year. We've learned a lot about our ecosystems for different reasons. So I'll be talking about harmful algal blooms, acidification, and Superstorm Sandy. And then hopefully talk about things that could potentially be done to hopefully reverse some negative trajectories that we're seeing in our coastal ecosystems. So can I recap 60 years in 5 minutes or less? Let's see if I can do that. I'll start with the story of Suffolk County, which grew from less than 100,000 people in the beginning of the 20th century to now more than 1.5 million people. There's more people living in Suffolk County now than in Nassau County. And you can see a lot of that growth happened in the middle of the 20th century, but really continued on through the latter half. Now, unfortunately, much of Suffolk County was built without regard to how we were going to deal with our household waste. We had sewage treatment plants in the western extreme of Suffolk County, but the large majority of Suffolk County, more than 70% of the homes, are not connected to sewage treatment plants, and therefore they have septic tanks or cesspools, and the contents of those progressively leach into our groundwater, and from there that groundwater is leaching into our coastal ecosystems. Now you saw the growth of Suffolk County through the 20th century, and the important thing to recognize is the time frame with which things happen. When a septic tank or cesspool is put into the ground, it takes years of use for that septic tank to come to sort of equilibrium with the local groundwater, maybe even beyond a decade. In addition, it takes decades for groundwater to travel from the center part of Long Island all the way to our coastal ecosystems. And I say that essentially to give you the sense that the groundwater that's now entering our coastal ecosystems likely originated from septic tanks and cesspools decades ago. So it's really that growth that we saw in Suffolk County is only now beginning to be manifested in our coastal ecosystems. And that's showing up in some of the data. This is data from Suffolk County, their Comprehensive Water Resources Management Plan that was recently released, that showed some trends that were surprising and in some cases disturbing. It essentially showed over an 18-year period how the groundwater in the upper glacial aquifer as well as the Magathy aquifer, the concentrations of nitrogen jumped in a very short period of time. So a 40 and 200% increase in these two aquifers in only an 18-year time frame. And again, this is a county-wide survey, so these higher concentrations of nitrogen are now making their way into our coastal ecosystems and will continue to do so. And models suggest, based on the growth that's experienced, that these trajectories, increasing levels, will continue in the near future. Now, another thing that's important to talk about as far as background is harmful algal blooms. So this is a growth of single-cell phytoplankton, algae, suspended in our waters that can discolor the water and often have negative effects on ecosystems or even human health. And what I've put together here is sort of a timeline of how these events have occurred over the last 60 years or so. If we went back to the 50s, Moriches Bay did not have, or it had an inlet that had actually closed. And maybe that'll be a recurring theme tonight. With the closure of the inlet, we had the onset of some green tide blooms. There were also, of course, duck farms there fueling those green tide blooms. But the inlet reopened in 1954, and we had an amazing 30-year period here on Long Island where there were no reported harmful algal blooms. And in addition, we had unprecedented landings of hard clams and bay scallops, the top fishery for both of those shellfish on the east coast of the U.S. Starting in 1985, however, we had a series of new harmful algal blooms showing up that had not been previously reported, at least at very high densities, having negative effects on the ecosystem. So brown tides in 1985, and in the last decade, things like toxic cyanobacteria, dinoflagellate red tide blooms caused by different species, in some cases discoloring the water and having a negative effect on the ecosystem, in other cases being a human health threat. And I'll detail this a little bit going forward. So if you look at a map of Long Island now, you can see that many of our coastal ecosystems are experiencing these harmful algal blooms. Different species, different locations, but really our whole South Shore and East End are blanketed with different harmful algal blooms. And in some cases, for example, Shinnecock Bay is a location where you have 3 different harmful algal blooms occurring in a single year. And I'm going to not detail the research on this too much, but you can go to the literature and read for yourself the research we've been doing here for the past decade plus that essentially has made very close links between enhanced nitrogen loading and the occurrence of these harmful algal bloom events. I'm going to just show some of this research, but you can go to these references, and I've talked about this through the years, that when we increase the amount of nitrogen, we're seeing more intense harmful algal blooms than we had seen in the past. And this has a negative effect on our important fisheries, as I've already said. Our shellfish, scallops, and hard clams have declined tremendously from, say, around 1980, declines of almost 99% of our landings. The distribution of eelgrass beds, essentially they've retreated through much of the Peconic estuary. So overall, a situation whereby our ecosystem with robust fisheries have changed, and with enhanced nitrogen loading, we have negative ecosystem impacts such as harmful algal blooms, loss of shellfish, loss of eelgrass, and in some cases loss of salt marshes. And along with that, recently the New York State DEC declared the entire south shore of Long Island, so Shinnecock Bay to the western bays and Hempstead, as impaired water bodies due to problems with on-site waste disposal. So that's the background. I don't know if that was 5 minutes, but I now want to talk about what happened in the last year and how that all ties in, because in the last year there were some remarkable occurrences, some of which are out of our control, but what I'd like to end with eventually is talk about the things that we can control. So I'll start out talking about temperature. This was probably lost in Superstorm Sandy, but 2012 was the warmest year ever in the United States. And not even close to previous years. And we don't need to just talk about the U.S. It was remarkably warm in the Northeast. So this is the National Marine Fisheries Survey of Northeast temperatures, and you can see last spring temperatures running 5 degrees Celsius above average. That's approaching 10 degrees Fahrenheit. So very, very warm water last spring. And here's a record that goes back to 1850, looking at the January to June temperatures. And again, remarkably warm not seen in the last 150 years, as long as we've been measuring. Those warm temperatures in the spring had a big impact on the way things played out on our coastal waters last year. And I'll start talking about Alexandrium fundiense, one of these harmful algal blooms. And this one's harmful because it's harmful to human health. It makes this compound here, saxitoxin. That's a neurotoxin. And in high concentrations, it would be quite serious. You can see it causes paralytic shellfish poisoning because it can accumulate in shellfish. And in some cases, where shellfish aren't closely regulated, it can cause deaths in humans at high levels. Now, again, I'm not going to go over all the research, but one of the publications we've published recently on this particular harmful algal bloom species by my graduate student, Teresa Hattenrath, publication shown here. She had a lot of nice and elegant data clearly showing that if you have more nitrogen in the water column, these events are more intense and they're more toxic. They have more toxins per cell, and she used isotopes to trace where the nitrogen was coming from in these cells that form these blooms, and it was coming from wastewater. So that's something we already know. Now, looking at the climate change issue, here are the dynamics of these blooms in Northport, west of here, over the last 6 years. And I'll point out a few things. There's a lot to look at here. The bottom line, of course, is these events occur in the spring. You can get that. Otherwise, I'll point out some other features. With those really warm temperatures, we had the emergence of the blooms last year earlier than ever before. But an important thing, going back to how things are changing on Long Island, there was a study done in the 80s looking at hundreds of samples across all of New York. Same exact species, they never had levels above this. And I note to you that this is a log scale. So this is 10,000 cells per milliliter. This is a million. So things are changing. And now this is all of New York. If you want to look at just what was happening in this system where they were measuring, you can see the change is even more dramatic. Orders of magnitude more intense now than it had been in the past. This is leading to shellfish bed closures because the shellfish are accumulating these toxins to a level that's harmful to human health. But 2012 was different because it wasn't just in Northport in 2012. These events spread. And we saw them on the east end more than ever before. In Shinnecock Bay, for example, was closed for more than a month because of PSP. Out in Sag Harbor and on the North Fork in Mattatuck. And these were first ever events for both Mattatuck and Sag Harbor, only the second time ever in Shinnecock Bay. And this shows you the trajectory over the last 7 years on Long Island. This is the acreage of shellfish beds that have been closed due to PSP, starting in 2005 and now moving forward to last year. Each year is a sum for that given year. So we're not summing from the past, but we're looking at each year all together. Now, it starts in 2005. I could go back to the 70s. They've been monitoring since the 70s. We never saw PSP before then. Showed up for the first time in 2006, and you can see what's happened. The locations have expanded, and you add it up to 2012, there being more than 13,000 acres of shellfish beds closed due to PSP. And this is the distribution of those cells all across Long Island. And in the red are areas where we have more than 1,000 cells per milliliter, and they correspond with areas where we've seen the PSP events, or areas that are already closed to shellfishing that are having high cell density. So you can see, if you look at the areas that are, say, green or so, or other red areas where you haven't had an event, there is the potential for these events to continue to expand. I'll point out another species that seems to be expanding, another dinoflagellate that's known as Dinophysis acuminata. Causes a different syndrome, diuretic shellfish poisoning, a gastrointestinal syndrome, and it makes a different compound here, okadaic acid. And again, similar pattern with to Alexandrium. Here's what we've seen in Northport, an area where it's been happening very intensely. Similar patterns, happens a little bit later, but again, you can see that temperature effect. Early warm temperature in the spring brought the onset of these blooms much earlier. But again, in this location, we've got a historical data set to go back to. People were looking for this species. It's been around for decades. We know there were surveys done in from 1971 to 1986. That's 15 years of data, thousands of samples. The highest they collected in 15 years, thousands of samples all across New York, was this. And you can see, again, this is orders of magnitude change. It was 10,000. We're now at 1 million or higher. So again, things are certainly different. And for what it's worth, I was at an international conference in Korea in the fall, and they saw Teresa, my student, presenting this data, and the people who are the world's experts in dinophysis said, oh my gosh, that's a world record. We've never seen those densities that high ever. Not a distinction we want to have, but that's what's happening here in our coastal waters. And I should say that this 2011 peak was broken in 2012 in Meeting House Creek in the Peconic Estuary. I'll show a little bit more on that, but this is a toxic species. The toxins are getting into shellfish. These are shellfish that Teresa collected. I'll note the FDA sets a standard of 160 nanograms per gram of tissue. Thankfully, in these areas with the star, the shellfish are exceeding that by an order of magnitude, but these beds are closed for pathogen purposes already. But there are cases where they're exceeding that and the beds weren't closed because New York doesn't have a plan in place yet to deal with this. It's a new and emerging issue, so things are changing quickly. But this is, again, a widespread species. You look here, these are the densities we're finding all across Long Island. And I'll note that of 20% of these sites, 20%, their peak densities, and just monitoring over a year and a half or so, 20% of the sites exceeded what had ever been, that had been recorded in the 70s and 80s. So, you know, Northport exceeded by 2 orders of magnitude, but 1/5 of our sites are doing the same, are showing the same characteristics, more dense than had been recorded in a very robust prior study. Moving out here to the east end, here's a nice shot of Great Peconic Bay, looking at the Shinnecock Bay and the ocean. In the late summer, these waters have been looking more like this. This is Coclodinium polykrikoides, another dinoflagellate. Thankfully not harmful to human health, but it is a serious ecosystem threat. This is what the cells look like under a microscope. This is what the water looks like, and this is what we saw at the Southampton Marine Station here in 2008. We very quickly learned that, yes, this is what they call ichthyotoxic harmful algal bloom. The fish are kept in captivity and exposed to these blooms, they expire. Now, thankfully, we believe in most cases the large fish, when they're in a patch of this and they're out in the wild, typically swim away because we haven't seen a lot of fish kills associated with this particular bloom. But we know in lab studies, in 30 minutes, we can have very rapid mortality, or 100% mortality, of all the fish that we might expose to this pure bloom water. And you really need to essentially remove all the cells to have all the fish survive. This species is also toxic to scallops. Here are experiments looking at both just pure bloom water or an isolate of just these cells, and you can see under a short exposure, just 3 days, you know, there's some or complete mortality depending on what the exposure is. Now, things changed last year. Last year was a very warm year again, and we don't have the data to lock it up, but what it's looking like is the warmer the year is, the more intense these blooms are because they start earlier. 2010 was very warm, 2012 was very warm. The blooms start in July instead of August, and they get more intense. And we saw, for the first time last year, a fish kill in the Peconic Estuary that was out in the wild. So not captivated fish, but fish in a creek. We thought, oh, it could be low DO. I showed up there with Suffolk County Department of Health Services. The oxygen levels were super saturated, so 15 milligrams per liter, and fish still gasping for breath. I don't have time to explain why it is, but the oxygen in the water is fine. They're just not getting the oxygen because of the toxin associated with this species. Now, some of you may be aware that we had a big loss of scallops in the wild last year as well. The scallop densities looked very good. It was setting up to be a great scallop harvest in the beginning of last summer, but there was a very large die-off prior to when the harvest started in November. I have some data here from the East Hampton Shellfish Hatchery showing the densities at a preserve they have in 3 Mile Harbor. They had very high densities leading up to the occurrence of these blooms. These blooms started late July, continued all the way into October, and the densities were much lower. Now, I don't have the data to say this is cause and effect. And frankly, being a very hot year, these scallops were probably active through the winter and had a lot of other stress going on as well. But we certainly know that having this red tide coupled with these very warm temperatures couldn't have helped. And we also know that this trend that was seen here was really seen in many places throughout the Peconic Estuary. Last group I'll talk about, just focusing on harmful algal blooms, the freshwater cyanobacteria. These occur exclusively in freshwater. Typically, the species we most commonly see are microcystis, and they make the toxin microcystin. This is a liver toxin. And here you can see a couple of our east end lakes and what they look like during the summer. But we had an unusual, well, those are some of the most toxic. This density, this graph here shows more than 20 different freshwater systems across Suffolk County and the levels of toxin that have been seen in them. Now, thankfully, we don't drink our lake water here, which in some parts of the world they do, and this is a serious concern. But the World Health Organization does set what they call low recreational risk level, and you can see some of our systems are above that. And then, in addition, in 2012, it was extremely warm, and we know that cyanobacteria, like some of these other harmful algae, really thrive under warm temperatures. The warmer it gets in many cases, the more intense these blooms get. This is a paper that was published in Science just a few years ago. And we had an extremely unfortunate incident last fall in Georgica Pond, where a dog died in Georgica Pond, and pets can die. But in this case, the evidence linking this event to these cyanobacteria blooms, unfortunately, was rather conclusive. There were several dogs in the pond. One of them collapsed. Some of the other dogs made it out. This particular dog was taken to a vet and taken to an animal hospital. It died in the animal hospital. The person had an autopsy done. It died of liver failure, and it had the microcystis in its stomach, which, again, just saying once again, the microcystis makes the microcystin the liver toxin. So this is one of the more conclusive cases. It's not unprecedented. This sort of thing has happened before. I don't think, as far as I know, it has not happened in Long Island. It did happen recently, a few years back in upstate New York. But this is some of the unfortunate consequences. For whatever reason, it's been known that dogs, when they see this green water, sometimes go after it and lap it up. Now, by the time we found out about this, Georgica Pond was clear. So we don't know what was actually happening at the time. The New York State Department of Health contacted me several weeks after the event to ask what I knew about it. But again, these cyanobacteria, and actually all these events, we do know are made more intense by heavy nitrogen loading. Okay, switch gears slightly, but it will be on the same topic. I want to talk briefly about the process of ocean acidification. Talked about this over the past several years, and I'm going to talk about it tonight because it too has a very close link to nitrogen loading. So this is a process scientists actually have only been thinking about for the past decade or so. So if you go back to an oceanography textbook from a decade ago, you wouldn't find this word, but it's really front and center in the minds of many oceanographers these days. And essentially the idea is that increasing levels of CO2 cause a series of complex reactions that create hydrogen ions. Hydrogen ions lower pH, and hence the term acidification. The water becomes acidified. And that has negative consequences for organisms that make a shell out of calcium carbonate, because the hydrogen ions pull that out, and then the carbonate is not available for these calcifying organisms. And thus far, people have thought of this as a climate change issue. Going forward, in the next 100 years, CO2 levels will go up in the ocean, pH levels will go down, and it will be a problem. And I've talked in the past few years about some research we've done on this particular topic, essentially showing that increasing levels of CO2 are problematic and lead to enhanced mortality of larval shellfish. Not only enhanced mortality, but also makes them significantly smaller. And we've also recently found that even larval fish can be negatively affected by increasing levels of CO2. This is the percent survival of a forage fish. And you can see their survival rates decrease with increasing levels of CO2. What we're now beginning to discover is that acidification is not just a climate change issue, and in fact, in coastal ecosystems, it's a 2013 issue. And people are recognizing that heavy nitrogen and nutrient loading in coastal waters that simulate algal blooms that eventually decay are going to do the same thing that's happening with our atmosphere. Put more CO2 in the system and drop the pH. And this just shows you that process, that any process that breaks down organic carbon and consumes oxygen is also going to produce CO2. And so maybe you've heard about the concept of hypoxia, which is low oxygen in coastal waters. So the same process that leads to hypoxia and low oxygen is also producing carbon dioxide. And for those of you who don't know, Long Island Sound is hypoxic every single summer. And as far as we know, this just shows data over a 20-year period since 91, but this goes back to the early part of the 20th century. Every year, it's hypoxic. And the question is it also acidic? We've begun to look at this question. Here's some data that was put together by my student Ryan Wallace and some cruises we did last August. And what you're looking at here is Long Island Sound from Port Jefferson going all the way west to the Throgs Neck Bridge. And you're looking with depth. And we've made these as heat maps. So you can see how this particular plot is oxygen. So we have low or no oxygen in western Long Island Sound, just like I showed you we always have. But what we're finding is that those areas with low oxygen have very low levels of pH. Normal pH is going to be about 8, and you can see these are getting down to 7. And same with carbon dioxide. Normal carbon dioxide levels are going to be about 500, and we're seeing thousands of parts per million in the western part of Long Island Sound. And both this pH and these PCO2 levels are levels known to be harmful to marine life. And Long Island Sound is actually one of several ecosystems that we saw last year that had similar levels of pH and CO2. Now, moving closer to the east end here, we did have a brown tide last year. Didn't even get to talk about that amongst all the harmful algal bloom activity. It was fairly short-lived. It was in Moriches, Quantuck, and Shinnecock Bay. But during the bloom, we went out, and we specifically wanted to look at the levels of CO2 in the waters here in Shinnecock Bay. And so that's what we're looking at here. Here's the Shinnecock Inlet. Here's the Quag Canal. This is Quantuck Bay. And this is mapping, so continuous measurements we make. And again, they're color-coded, so you can get a sense. And with the upshot being, in the western extreme, the levels of CO2 are very high, 1,000 parts per million. Now, just for reference, I should have said this before, but we expect the open ocean to get to 800 parts per million in 100 years. And we're very worried about that, oceanographers, at 800. But you can see we're already at 1,000 in western Shinnecock Bay. This was particularly during a brown tide bloom. What we found most interesting is that we concurrently at several locations, as we went from Quantuck Bay at distance 0 to the canal, measured densities of brown tide. And what we found is that these very high levels of CO2 were concurrent with the brown tide, and the two parameters, brown tide densities and CO2 levels, are very closely correlated. And the pH, in addition to being high CO2, we also had very low levels of pH in this particular area. And the interesting thing is we looked at this monthly through the summer and saw that those acidic conditions were unique to the brown tide. Once the brown tide went away, the waters cleared up and the pH levels were much better. But we know now that in addition to brown tide, it's harmful in and of itself if the CO2 levels are adequate or where we want them to be and the pH is high. We now know that we have the dual threat from brown tides of both this pH problem, acidification, and the bloom itself. And we're recognizing now that some of these harmful algal blooms are probably leading to high levels of CO2 via shading or producing the CO2 themselves. And I'll briefly say that we've started thinking about what does it mean if you have both acidification and a brown tide happening. And we've recently put some data together that shows that the consequences of two together are worse than you'd predict from either particular stressor. So this is the survival of bay scallop larvae exposed to different levels of CO2 or to the brown tide. And you can see negative effects from the CO2, negative effects from the brown tide, and the combination leads to very low levels of survival. And this harkens back to some data I presented last summer that Brad Peterson and John Carroll had collected looking at larvae in Shinnecock Bay, specifically looking all over the bay here, and specifically tracking multiple species of larvae, looking at bay scallops, scapigula, art clams, blue mussels, all over the bay. And Some areas have these larvae showing up, some don't. But if you put this data that they collected against this map, what you find is the larvae are showing up here, where the pH levels are fine, and it's in this region where we're having this acidification that we're not seeing the brown tide, we're not seeing these larvae settle at all. And it's important to note that the brown tide's occurring when these larvae are in the water column. Just some further information on coastal acidification. The Forge River, probably most of you have heard of, is a eutrophic ecosystem a little bit west of here that experiences also low levels of pH, low levels of oxygen. So we conducted some experiments last summer to understand, okay, well, this acidification is going on. How might this water be affecting the survival of different marine organisms? So here's some experiments where we took that water, placed scallop larvae actually in the water itself, and amended it in a few different ways. If we didn't amend it, we had very low survival. But I'll just point out one quick treatment. If we add carbonate that fixes the pH problem, we have a huge jump in the survival by more than 30% or threefold higher. And similarly, we did some experiments. These are by Elizabeth E. Pasquale, who looked at the survival of larval fish, again, the same species I showed before, with and without the addition of carbonate. And again, if we can fix that pH problem with the carbonate, the survival more than doubles. So what this says is that coastal acidification is a 2013 problem. It's promoted by nitrogen loading and also brown tides. And it's going to get worse with climate change, because on top of the nitrogen loading, we know the atmosphere is going to continue to increase. And finally, I think we now have the data to say that it is likely reducing the survivalship of larval fish, finfish, and shellfish in our coastal ecosystems. Okay, the final, well, not the final section, but the next section, close to the final section, I just want to talk about Superstorm Sandy, another big looming event, obviously, for 2012. Changed many people's lives forever. In many ways, we were quite fortunate here on the east end. Places west of us were completely devastated and still are. But I'm going to talk mainly about the effects in the marine environment. And I want to first talk about flooding and shorelines. And I'm going to simply mention that if you look at the south shore of Long Island and how things fared during the storm, essentially, the regions that had well built up dunes and salt in the front of our barrier islands, for example, and salt marshes built on the back are some of the areas that survived the best. Now, we didn't get the storm as bad here in Shinnecock Bay as occurred points west, but in Shinnecock Bay, along Shinnecock Bay and Dune Road, we have some of the best dunes along the south shore of Long Island. There's been some great efforts keeping those dunes healthy. We have some of the best salt marshes along that area, and that was the only bay on the south shore that didn't breach. So it's qualitative information, but it just goes to show how important having strong dunes and salt marshes are for keeping those barrier islands intact. And unfortunately, in points west of here, many of those barrier islands have lost all their dunes and if there's another major storm, could be in trouble. And we know the areas that did very poorly are the ones where there was no dunes whatsoever. And those that were built right up to the shoreline, unfortunately, took the brunt of the storm with no protection. So clearly, having a natural front dune and salt marsh was very helpful. Another impact of Superstorm Sandy I want to emphasize comes back to the nitrogen issue in wastewater, is that we had many sewage treatment plants that were very seriously damaged during the storm. Hundreds of millions of gallons of raw sewage went directly into our coastal waters. The Bay Park sewage treatment plant and Hempstead Bay being the one that was most prominent, and there were an extended period of time where raw sewage was going directly in to the coastal waters. And here you can see the flooding of the Bay Park sewage treatment plant and the impacts that that had. And immediately following the storm, all the shellfish beds on Long Island were closed, but it was for 50 days that the entire south shore, Great South Bay and the western bays, were closed to shellfishing. Now, initially, it would be assumed that this was from the Bay Park sewage treatment plant, but I want to point out that actually we had a 5-month shellfish bed closure associated with this storm. And the Bay Park sewage treatment plant is way over here, And we know that actually the water here is not getting over to this part. This is South Oyster Bay, incidentally, Western Great South Bay and South Oyster Bay. The fact that it took 5 months, it was just in the last week, in fact. I had to check last night, and it just reopened since the storm. And what this tells me, and I think other people need to be alerted, is that there are other wastewater handling facilities, be they sewage treatment plants, lines running to and from sewage treatment plants, or household waste handling facilities that failed during this storm and contributed towards, as I said, a 5-month Shellfish Bay closure. I should say, importantly, the New York DEC was trying on a weekly basis to reopen these shellfish beds. They were testing and kept finding pathogens in the water. So clearly there are wastewater infrastructure problems to deal with all across Long Island, from Nassau County here doing sewage treatment plants, and of course our septic tank and cesspool issue here further east. I want to briefly talk about the new inlet in Great South Bay. We got a beautiful picture here from Marshall Brown who put this up. And of the new inlet, this is Belport Bay. This is what the inlet looked like last month. And but before I talk about the inlet, I want to emphasize something to you. And I've talked about nitrogen, but if you look about a map here, where we're finding these harmful algal blooms, and people always say, well, why are we having these blooms? Is it just the nitrogen? And I often say no, because there's a second component. The areas where these are most intense are also areas that are very poorly flushed. So if you have restricted water movement and heavy nitrogen loading, that's the toxic combination that can lead to these blooms. So we instead have, in this particular situation, with the new inlet, we have changed the characteristics of Great South Bay. So this is some data from Charlie Flagg at Stony Brook University showing how the salinity levels changed as soon as that inlet was formed. This is specifically in Belport Bay, Great South Bay. And you can see chronically about 24 parts per thousand, and now higher, in this particular case, going up to 29. The inlet's grown since then, and in fact the salinities are even higher. We've done some mapping across Great South Bay looking at the salinities, and that's what's shown here. Here's the mean levels of salinity across Great South Bay before the inlet, and this is what it's looking like afterwards. And you can see these salinities, 32 is as high as it gets. That's full ocean water. So we've got a situation where the ocean, this new inlet is exchanging very nicely with the Moriches Inlet and flushing this part of the bay out significantly with ocean water. It's affected the nitrogen levels in Great South Bay. So here's a comparison of the total amount of nitrogen in the water in December 2011, before the storm, to December 2012. This is after the inlet was formed. You can see the ocean's not changing, but look at the big change in the bay water. You can see now the bay in that particular region looking a lot more like the ocean. So lower nitrogen levels. And more recently in March, again, my student Ryan Wallace and Mark Lusty were out mapping levels of chlorophyll in Great South Bay. And we took here, this is the 35-year average of chlorophyll levels in Great South Bay compared to what we were seeing in March. So this is I'm specifically I'm picking months because it's important you compare things seasonally. So we looked at December nutrient data because that's what we had. But here's chlorophyll in March, changes seasonally. But if you compare apples to apples, what you can see is that the chlorophyll levels in this part of the of Great South Bay and into Moriches Bay are very, very low. And this is an area that historically has been prone to intense algal blooms. And oftentimes of these harmful algal bloom species, even the Forge River, which is an area that's, as I already mentioned, has lots of problems, you can see, at least up until a certain point, has very low levels of chlorophyll and higher levels of water quality. And there's a lot of concern about flooding in these events, but again, Dr. Flagg at Stony Brook has looked at the water levels associated with different storm events. You can see there are flooding events, high water events that have occurred since the storm. This one, of course, is the storm. But we had a series of nor'easters come through in the winter. But what this data shows is that the extreme tides are happening in unison in Belport, in unison with other places like Lindenhurst and even Woods Hole in Massachusetts that don't have the inlet. So the conclusion is that the water levels are not being changed in this area by the new inlet there. And right now, I'd say the fate of the inlet is unknown. There is a plan to close it come this fall. There's a lot of people who don't want to see that happen, and we'll be out there monitoring the situation. And so stay tuned, because these flooding events are now gone, and going forward, we don't expect there to be any intense tides. It's typically high extreme tides are seasonal. And I just want to touch on the idea of global warming. Maybe some of you saw this issue of Bloomberg Business Week that came out directly linking Sandy to global warming. That's kind of dangerous talk, in that we can't say that global warming caused Hurricane Sandy, but there are things we can say. This map here shows the warming that's occurred across the planet. I'm just showing North and South America here over the last several decades. And the bottom line is our falls are significantly warmer now than they used to be. So if we had the temperatures in the past, with these warmer temperatures in the fall, it's increasing the likelihood that a hurricane that needs to feed off of warm water is going to make it this far north. It also is likely that warmer water, we had a very warm year, I already told you that, and the ocean got much warmer than usual. That probably led to a more intense storm. And as we continue to warm, that's going to favor stronger hurricanes and higher seas going forward in the future. So, what are we going to do, to borrow a phrase? Well, here are some take-home messages. We have issues, clearly, and some of them we're not going to get in front of and be able to stop. The global warming is proceeding. That's going to proceed. Even if we're able to fix the fossil fuel problem on this planet, we know that the planet will continue to warm. So warmer seas and more intense storms are something that we need to be aware of, that we can't control. But there are things that can be done about things like nutrient loading and other aspects. So I just want to touch on those as I close out. I want to mention the Shinnecock Bay Restoration Program, a collaborative effort at SoMAS. Brad Peterson is here, one of the PIs of this program, where we're looking to do things like, we call these in-the-water solutions. So not deal with what's happening on land, but what can we do to improve the quality of our ecosystems in the water? So, for example, we're doing things like planting clams and oysters, and over the past year we've planted millions of these, and we're going to continue to do that. This is a great partnership with the Southampton Town Trustees. They've shown great support. I know a couple of them are here tonight. I don't know if they're still here, but Eric Schultz and Bill Pell are both here, and they've worked with us to put in these shellfish, both seeds. We've been putting in adult shellfish as well. And going forward, some of you may be aware of the SPAT program put together by Cornell that goes on in Shinnecock Bay. We're partnering with Cornell because we want to build that program out. And actually we have sign-up sheets here, and if you're interested in helping to plant oysters to improve the health of our bays by increasing filtration pressure, please sign up, because we're going to have events and we're going to get people. Typically there's just a few dozen people doing this in Shinnecock Bay. We want to get 100 people doing that, and we think it's a great project for families, for children to be involved in. So please sign up, because this is a way that we can all make a difference together. Brad Peterson is going to be leading eelgrass plantings that are going to start later this month to expand our eelgrass beds in Shinnecock Bay. These are critically important habitats that have been knocked back by eutrophication, and we're looking to expand these to support our finfish and shellfish. And my student Alex Mintz is here, and Alex is working on the idea of harvesting macroalgae out of Shinnecock Bay, specifically to help remove nitrogen. It's a pilot project. There's a poster out there, so you can go and see that to learn more about it. There also, of course, needs to be other solutions beyond being in the water. So watershed solutions, so things like land preservation. I note that a lot of the land is spoken for, of course, across the East End. But I'll point out this area in Shinnecock Bay, two very large parcels of land. The largest contiguous open space in all of the town of Southampton is here, and there are plans to develop that land. But note what's around it. We have lots of development here in Hampton Bays, in East Quogue and in Quogue. There's also farms there, and we've recently been trying to understand what's happening in the watershed here already. So again, note where these areas are that may be developed. Here's what the groundwater looks like entering Shinnecock Bay. So we've been getting data about groundwater surrounding Shinnecock Bay, And here's what it's looking like in this particular part of western Shinnecock Bay. More than 6 milligrams per liter, which is significantly beyond the average for Suffolk County. In some places, we're seeing 20 milligrams per liter. And that's a very high level, and that's problematic. And that's before these remaining parcels have had their fate decided. So we already have high levels of nitrogen. Here's the area where the levels are fairly low, and that's where the open land is. So the question is, what's the fate going forward? I can tell you, if you think about Shinnecock Bay, it's already an area where, as I've emphasized this whole talk, where we have these harmful algal blooms. We've lost shellfish beds. We're not seeing the larval shellfish there. We've lost eelgrass. Acidification is happening. And we now know these very heavy nitrogen loading rates are present there, very high levels of nitrogen. So, you know, the fate going forward, well, those levels will continue to increase if that watershed is built out, or we can try to hold the line. The other thing that can be done is to actually work with septic tanks and cesspools. And there's more and more technology going forward. And in fact, there's a lot of businessmen very interested in this. And that's something that can bring down a price point. There's some competition for improving cesspools and septic tanks. So I just have an example of one here that's not too intrusive. Of course, this is a whole cutaway so you can see how the system works, but something that is just fitted right on to a septic tank. And so this is something that can reduce cesspool nitrogen levels from 80 parts per million down to about 2 parts per million. And that's pretty good technology, and that would make a difference in our watersheds. And this is just some modeling effort that shows if you have different types of alternative septic systems. This is Great South Bay, but here are the nitrogen loading levels if you do nothing. But if you start to change the homes and upgrade those septic tanks, you can see you can start to roll back the amount of nitrogen that's entering our coastal ecosystem. So things can be done. As I wrap up, I'll just mention that SCRP has a Facebook page. I've been told I should tell you to like us. And in addition, like us and then check in. So go ahead. Find us, like us, and check in right now. You had to have your cell phones up. You can put them on now. You can like us and then check in. We've established this page, and we're planning on using it going forward to essentially get the information that I just showed you out to the public on a more regular basis. You won't have to wait a year. In fact, some of the data I showed you just tonight, we put up in the last week. One of them, Marshall shared with his page. In 48 hours, 10,000 people saw a plot about salinity in Great South Bay. I guess that's what they mean when they talk about viral. And we plan on doing that going forward as we continue to monitor the inlet and other situations across Long Island. We want to get the data out and share it with the public. All of this research would not be possible were it not for the great activities of the students and researchers in my lab, and so I'm extremely grateful to them. And please go see their posters out there if you want to hear more about what's going on. I don't really know any of this. They're the ones who know it. Talk to them about it. So I'll wrap up by just simply saying two things. We know that excessive wastewater nitrogen loading from land is degrading our coastal ecosystems, promoting harmful algal blooms, hypoxia, acidification, and inhibiting fisheries and important marine habitats. And since we know that climate change is something that we cannot control, see those phones did go on, and that these will have a negative impact on our ecosystems, we need to control the things that we can and take actions on the things like nitrogen loads into our coastal ecosystems to help preserve them and preserve a way of life here on Long Island. So I'll conclude with that and be happy to take any questions. Yes, please.
Chris, not to be too pessimistic, if we were to stop the nitrogen flow right now, given the fact that there's so much already in the system, in the aquifer, how long will it be before we start changes?
So the question is essentially how long until, if we correct the nitrogen problem now, when do we see the improvement in our coastal ecosystems? It took time to get into the situation. It's going to take time to get out. But we now know, and I'd say the onus is now on us to take action. And that can be coupled with what I already talked about, the in-the-water solutions, which, you know, research shows that if you have a healthy benthic ecosystem, that can help control eutrophication. So I think the two-pronged effort does provide hope. Thomas.
One of the slides indicated, was there, I think it was one where, I don't know, it was more western Suffolk, the groundwater, where you had the overlay of the undeveloped that they're considering
Yep.
terminating the subdivision.
Yep.
And do they have data of actually like the inflow of the groundwater into the bays at whatever like bank seepage or is that just the existence of?
Well, the data I show is specifically the groundwater, the nitrogen levels in the groundwater. But we do have a model that we're hoping, I imagine next year this symposium will be able to present that actually shows the flow rates of the nitrogen from that groundwater and the precise impact it's having on different sub-watersheds across the South Shore.
Because that's where I thought there would be an opportunity. When I was at the forge, I did see the heavy development. I saw bank seepage. And you can just see it, physically see it.
Yep. And you can see it there. And again, I think next year we'll have the precise loadings from that. Kevin.
Can you speak to your experience in the work that you're doing now as it relates to the savage budget cuts that have occurred in the marine units at PPC and the health department, and whether what effect that's having on the ability of the region to sort of respond and recover to this? Good thing? Is it a bad thing? Does it matter? Does it not matter?
It certainly matters. It's certainly not a good thing. The question is, how are budget cuts to agencies such as the DEC and the county affecting all of this? And it's not a good thing. Certainly, places like DEC, for example, there are things going on they just can't respond to because at this point they don't have the personnel. For example, the inlet, the DEC's not responded to and has not been monitoring. The county has been doing some monitoring work, but at the same time, not at the level they've been able to do in the past. And some of these harmful algal blooms, they're having DEC, for example, is having trouble keeping up. New bloom emerges, and suddenly they don't have the personnel to respond in the way they'd like to. So certainly, it's not helpful at any level. Yes.
You saw the temporary inlet that was created by Superstorm Sandy. Would it make sense to try and create periodic artificial inlet openings to help flush the bay and then seal them up because you noticed the reduction in the nitrogen and it flushed out into the ocean? Would that be a way to keep some balance in the bay?
Yeah, so for those who didn't hear, the question was about the inlet and the idea of creating an inlet that you could actually control. And actually, honestly, that's probably the best solution that we could have. There's a lot of controversy about the inlet. People are concerned about flooding, protection of their homes, and if we had an inlet that we could open and close, that would present. And because frankly, there are certain times of the year we don't necessarily in the winter. The flushing probably isn't quite as important, and that's where it's more likely to flush. So I think we're probably decades away from having something like that. But for example, here on the East End, if I were made king for the day, I'd try to put a temporary inlet, say, in Quantuck Bay, because that's an area where we need the flushing, and that would be very, very useful. So we may be there. Maybe when I'm retiring, we'll have one of those, but we're not there yet. But I honestly, like I said, it is the combination of heavy nitrogen loading and poor flushing. So I think I don't know how we'll get there, but what you're talking about is not is something I've thought about as well. Yes.
With regards to the acidification as it relates to shellfish growing beds, is there any mitigation measure that could be maybe man-made applied to the substrate to counteract that?
Well, so the question is about acidification and things that you could do to counteract. I know in hatcheries now, where they are spawning shellfish, certain hatcheries are now aware of this acidification issue, and they are taking action. They're essentially trying to use base to keep the acid levels, keep the pH up and the acid levels away. In fact, for example, on the West Coast in Washington State, they had 5 years in a row of no settled oysters in hatcheries. And they finally figured out, oh, it's because our water's acidic, because of upwelling and probably partly related to eutrophication as well. So at least in a hatchery setting, that can be done. And I do know some people are thinking about similar things within specific shellfish beds. And you know, one very important thing on this front, if you think about shells themselves, you know, there's a lot of carbonate in shells. So when you remove that carbonate, that's probably changing the chemistry of the system. So another thing that can be done is shells that are coming from the shellfish, the shells can be put back. And at least on a local scale, that could have potentially a positive impact.
Chris, are you a fan of pelletization of the sewage?
Pelletization. I guess it depends what you're going to do with it next.
Because I know they do that up.
And then you mean transporting it out?
Yeah.
Well, I mean, you know, frankly, a lot of the sewage treatment plants, if you look at, you know, I've worked with the sewage treatment plant, looked at the system like in Bay Park, Jamaica Bay, Northport, and, you know, wherever they're discharging, there's a problem. So if it can be pelleted and removed, that would probably be helpful, I think. Not aware of that technology, though, frankly, but I think it could be good. Yes?
Yes, Chris. Earlier this year, after Superstorm Sandy hit, there was a document that was being put up at the state of recommendations for dealing with it through either oyster reefs or salt marsh reestablishments and dunes. And I was just wondering if you've heard anything about if that's gone forward or state funding for that type of those types of projects or happening in the near future.
I happened to be in a meeting with the Army Corps of Engineers that were the recipients of $5 billion from the Superstorm Sandy relief fund, and they are looking at a lot of restoration efforts. In that meeting, their feeling was that oyster reefs were not a good first line of defense.
Right.
But they are fans and are looking at some of the other things I talked about. So the idea of building up dunes with beach grass in the front and building up salt marshes in the back is one of the several approaches they're thinking about and maybe enacting going forward. So, yeah.
Yeah, it seems like one of the problems is cesspools. Is there any move afoot in Suffolk County or Southampton to cause some kind of legal status to improve them? Or?
Well, I know that any decision made on cesspools and septic tanks will go through Suffolk County Department of Health. And they're working towards approving additional alternative septic systems. So we had a representative from the health department here, I thought, Office of Ecology. So I think, how many systems are approved right now?
Well, the systems that are approved now are really more for a sewage treatment plants.
Okay.
You're alluding to the packaged plants?
I was thinking about things like...
single-family residence type systems, there's nothing approved yet.
okay. But there, I know that...
But, you know, for small developments, there are a number of small packaged plants that can, you know, service a small area.
And I know that I believe the county is looking into approving single-home alternative septic systems.
The second part of the alternative on-site sewage disposal systems should be going forward soon.
Yeah, so there's interest for sure. I know that Southampton Town recently was considering incentive plans for improving septic systems. That was very recent. I don't know where that went.
That was a hearing last week. The inclination is that they will act favorably on that initiative.
So things are moving in the right direction. And again, I think my feeling is that will continue to happen. And my feeling is that the technology is moving along. Some people say, oh, it's going to cost, you know, tens of thousands of dollars, but there's new systems coming along that are a lot less than that, a lot smaller, and a much better price point. So I think, you know, again, may take time, but I think things are moving in that direction because it's, you know, the consequences of not doing anything are now become clear. Tom.
Chris, would the coastal estuary research program here consider that additional shift in its mission? Could this be a place where we bring some of the market demand and some of the very close regional issues to that some of those developers of technology could be sitting next to the people who allow the permits to happen. Yes, there's people inventing things, and yes, there's pockets of really high demand and other areas that don't need it at all. And it's not really clear who does and who doesn't need it. Could this center help that convergence of thinking? Or maybe it's happening at Manhattan College, I don't know it.
I think there are opportunities for that. I mean, I think the idea is looking at the efficacy of the different alternative systems at multiple levels. I think it's important to understand how they're working in a lab setting, but also in a field setting. And you know, certainly anything. Our group communicates frequently with the county, and you know, maybe less frequently with some of the technology firms. But we have heard from them, and you know, we'd be happy to play middleman. Any further questions? Yes, sir.
Would the dredging of the intercoastal have any positive impact on the flushing of the bays?
Yes, certainly, and that's been going on. You know, I believe, and I'm actually getting data on this. Requested it today. There's been dredging going on in the Shinnecock Inlet, Moriches Inlet, and the Fire Island Inlet. So, oh well, I mean it would depend how that's done. Frankly, flushing. One of the big things that affects flushing is going to be the precise area in the inlets between the ocean and the bay. That's the most important. If that's affected, then that will increase the flushing. Whereas if it's actually in the bay, it might affect things regionally, but it may not affect the net flux of ocean water into the lagoons. Eric.
No, Chris, maybe you can bring up the fact we do have a model of a flushed bay, Shinnecock Bay.
That's right.
And we have no brown tide in that, and there's a lot of stressors on that system, and the trustees actively monitor that bay for the shellfish harvest there. Weekly dissolved oxygen and salinity checks on it.
Yeah.
And that shows you how that flushing can have a beneficial effect on the ecosystem.
Yes, just to follow up, so this is Eric Schultz, president of the Southampton Town Trustees, and going back centuries, the trustees have been purposely making an inlet in Shinnecock Bay, so the next would be the next Barrow Island estuary here, and it opens and then it closes naturally, and it's frankly the most productive wild oyster bed in New York State. It's a small bay, but you can't find oysters that dense anywhere in the wild. And so clearly the idea of being able to flush that out via the inlet is helpful and gets it a good mix. And, you know, of course I did a study for the trustees about a decade ago now, but it clearly showed that it has a big impact, but, you know, essentially a positive impact ecosystem-wide at least.
Since 1642.
1642, okay. Centuries.
Every person, as in the town law, every person from 16 to 60 had to report down to the cut to dig it open on a routine basis.
You don't still hand out the shovels, though, do you?
No.
Any further questions? Yes, sir.
Yeah, you've been talking about nitrogen from waste. Does that mean that nitrogen loads from fertilizer, stuff like that, are really something to worry about?
That's a great question, and I was remiss to not address that issue because in former presentations I have. But what we can say is that at least on the South Shore bays, the primary source of nitrogen is coming from wastewater, and that models have been done to show that. That being said, you can move to other places to find a different scenario. So that, for example, in the Peconic Estuary, there are regions where there's very heavy agriculture, and fertilizers are the primary source of nitrogen. You can go way out to the east end, and it's actually the atmosphere, because there's not a lot of land around there. And certainly fertilizing anywhere increases the amount of nitrogen. So even if it's not the most important source of nitrogen, it does increase the total amount. And therefore, if there was less fertilizer going on, in addition to improved septic tanks, you'd get an even better response than you would without controlling fertilizer alone. Thank you for asking that question. Yes.
Is there a way to treat the water that's actually in the water aquifer already, suck it out and treat it?
There are, sucking it out is probably not a great option because unfortunately the high levels of nitrogen are fairly widespread. So when you have, for example, a toxic plume, they do that. So if someone spilt some terrible organic chemical or gasoline, that can be done. In this case, it's so widespread, that's probably not an option. There are technologies, actually, to set up barriers such that as the groundwater flows through that barrier, the nitrogen levels are reduced. So that technology is out there. It's not that widely used, but it can be done. Okay, I think I'm going to wrap it up. I'll remind you that there's some great posters out there, and the students are now running to those to man their posters to take additional questions from you. So remember, our next lecture on salt marshes by Dr. Judy Weiss will be the first Friday in May. Like our Facebook page. I'll go back to that. And thank you for coming. Good night.
First of all, really wonderful to take what you just did there and chop it up into bite-sized YouTube videos.
Yes.
So whoever your AV guy is.
Yes.